Hello guys, in this lecture we will discuss about the eigenvalues and the eigenvectors. So this is a very interesting topic. In this lecture we are going to discuss the definition of eigenvalue and the eigenvectors, and then we will see with the help of an example that how we will find out the eigenvalues and the eigenvectors, and then we will discuss some very interesting properties of these eigenvalues. I hope that you will enjoy this lecture. So let us start with the definition of eigenvalue. Suppose we have a square matrix A, then a non-zero vector x is said to be an eigenvector of eigenvector if this ax is some scalar multiple of x. It means if you can write down this ax is equal to this lambda x, then this lambda is said to be an eigenvalue of a, and x is said to be the corresponding eigenvector. So from this equation we can write it down like this. We are multiplying here with the identity matrix because we can subtract two quantities only when they are in same unit. So just take x common out. Now if you look closely to this equation, basically this is a homogeneous system of linear equation, and we know that a homogeneous system of linear equation has a trivial solution if the determinant of a is non-zero. But we know that here our x is non-zero, that means we are searching for non-zero solution. So this is possible only when the determinant of a minus lambda I is 0, and this equation is called as characteristic equation of the matrix A. So the roots of this equation will gives you the eigenvalues of the matrix A. So that means if we have to find the eigenvalues, then we will write down first the characteristic equation, then we will simplify it for the roots. So let us see with the help of an example how we will do it. Suppose we have this matrix A. We have to find out its eigenvalues. So for finding out the eigenvalues, first we will write down the characteristic equation. So the characteristic equation of matrix A, we know that is given by determinant of a minus lambda I equals to 0. So if you see the matrix A minus lambda I, it is what basically I is the identity matrix. So if you have to obtain this matrix, just write down minus lambda in the main diagonal of the matrix A. So this will be 4 minus lambda 0 1 3 minus lambda. Now we know that how to find out the determinant of a 2 by 2 matrix. If we have a 2 by 2 matrix A, B, C, D, then its determinant is given by AD minus BC. So from here so these are the two eigenvectors of the matrix A, as it was expected, because if we have a 2 by 2 matrix, then we will have two eigenvectors, eigenvalues, and if we have a 3 by 3 matrix, then we will have 3 eigenvalues. Okay, so let us say that the lambda 1 is equal to 4. This is the first eigenvalue, and lambda 2 is equal to 3. This is the another eigenvalue. Now we will see that how to find out eigenvectors. So first, corresponding to lambda is equal to 4, suppose x1 x2 be the eigenvector which is corresponding to lambda is equal to 4. So from equation we have 4 minus lambda 0 1 3 minus lambda, because this is a 0 matrix, so it will be 0 0. Because we are searching corresponding to lambda is equal to 4, so if you put lambda is equal to 4, so you will have 0 0 1 and minus 1. Now just do the multiplication. You will have 1x1 minus x2 is equal to 0. That means you have, or we can say that all those vectors which have first and second component same will be the eigenvector. So for a particular case, we take or just for a particular element we take, suppose x1 is equal to 1. So we can say that the vector x, so x2 will be 1 also. So this 1 1 be the corresponding eigenvector. Similarly, we can find out the eigenvector corresponding to lambda is equal to 3, or you can see that how we will do it. So again we consider that suppose x is equal to x1 x2 be the corresponding eigenvector, then again from the equation, so we have 4 minus lambda 0 1 3 minus lambda. Now just put lambda is equal to 3, you will get 1 0 1 3 minus 3, it will be 0 x1 x2, this is equal to 0 0. So just do the multiplication, you will have, that means you have just this system of linear equation. You can see here that x2 is not present in the system, so it means your x2 is arbitrary. So in other words, you can say that any vector whose first component is 0 will work as the eigenvector corresponding to lambda is equal to 3. So take any value for x2, I am taking suppose x2, or take x2 is equal to 10. So this will be the corresponding eigenvector corresponding to lambda is equal to 3. I just take the value of 10. You can take any value. Any value for x2 will work as an eigenvector. Okay. So I hope that it will be clear to you now how to find out eigenvalues and eigenvector. So now we will see some alternate ways to write characteristic equation for 2 by 2 and 3 by 3 matrix. For 2 by 2 matrix, because we know that we will have 2 eigenvalues corresponding to 2 by 2 matrix, that means our characteristic equation will be a quadratic equation. So how to write down that characteristic equation for 2 by 2 matrix? So you will have a lambda square, trace of the matrix A lambda, and the determinant of A equal to 0. So this is plus minus plus. That means lambda square minus trace of the matrix A as the coefficient of lambda plus determinant of A is equal to 0. So this is your characteristic equation for 2 by 2 matrix. This equation gives you two information. First information is about the trace of the matrix, and second thing, it will gives you something about determinant of A. So that means if in some multiple type questions, if they give you only characteristic equation, so from that characteristic equation, you can find out what is trace of A and what is determinant of A. So you can identify what is the trace of the matrix and what is the determinant, even if the determinant is not given in the question. That's why I think that it might help you. And if suppose you can see just in the previous example, the matrix was, so its characteristic equation will be lambda square minus trace. You know that what is trace? Just the sum of the diagonal entries, which is 4 plus 3 plus determinant of A, 4 into 3 minus 0, that means this is 12. So if you simplify quadratic equation, and which is the same equation which we have just find out, it will gives you the root 4 entry. Okay, so that means if they give you this equation, so you can say that this characteristic equation which is given to you, the matrix corresponding to it will have determinant 12 and has trace as 7. Now if suppose we have a 3 by 3 matrix, that means the characteristic equation will be our cubic equation. It will have 3 roots. So this will be lambda cube trace of A lambda square lambda determinant of A equal to 0. This is plus minus, or that means you can say that this is lambda cube minus trace of A lambda square plus sum of the cofactors of the diagonal entries So from here, this is the characteristic equation for the 3 by 3 matrix. Now let us discuss some properties of the eigenvalues. So the first property is that if you have a matrix A which is either upper triangular or lower triangular or diagonal, if you have any one of the matrix in this form, then the eigenvalues for such matrices are nothing but the elements of the diagonal entries. For example, if you see that in the previous one, the matrix was 4 0 1 3. So if you see that this is matrix is what? This matrix is lower triangular. So the eigenvalues are nothing but the elements of the diagonal entries, which is 4 and 3. There is no need to find out characteristic equation to calculate the eigenvalues. You can write down directly. Second property is that the sum of eigenvalues of the matrix will nothing but it will be the trace of the matrix. So this property might help you that you have find out the correct eigenvalues or not, so that you can add them and you can see that the trace, if they are going to be same, that means you have find out correct eigenvalues. The third property is that the product of eigenvalues is nothing but the determinant of the matrix. So this is also some quite interesting property, because if suppose you have some eigenvalues lambda 1, lambda 2 and so on, and you have 0 as one of the eigenvalues, so if you find out the product of eigenvalues, so it will be 0, and by this property it comes out to be the determinant of A, and we know that if the determinant of A is 0, then the matrix A is singular or it is not invertible. Now the next property regarding the eigenvalues, suppose you have any square matrix A having eigenvalue as lambda, then powers of the matrix A to the power m has eigenvalue as lambda to the power m, where m is any positive integer. Second point is that if matrix A have eigenvalue as lambda, then A inverse has eigenvalue as 1 upon lambda. And the third point is that A transpose has same eigenvalue lambda. So these are some properties of the matrix. Okay. So I hope that this lecture helps you.